Hi everybody, welcome to WasleyScience. In this episode, we are going to talk about weathering and erosion. So let's get started. Alright, let's start with a background check. So you see a brand new sidewalk on your local street. The concrete has hardened and it's ready for pedestrians to walk on it. What kinds of things could happen to this sidewalk over time? So remember, we're talking about weather and erosion right now. So what types of weathering or erosion can happen to this sidewalk over time, over years, 10 years, 15 years, 25 years? I want you to write down at least 3 things right now and press pause on the movie. Alright, so what I have for the sidewalk is it could get chipped or cracked. Pebbles can get exposed at the surface, so what that means is that the concrete material can start to become exposed and then get pushed away from the sidewalk. And then a tree may heave the sidewalk with its roots and cause it to lift the sidewalk up. So first, let's talk about the plate tectonics. I know we talked about it last movie, but the thermal energy from the Earth's core drives the movement of plate tectonics. And plate tectonics do have a role in weathering because as the plates move, they do sort of erase things that have occurred millions of years ago. Now, what drives weathering? Weathering is driven from the sun. The sun drives the water cycle, which creates the rain. Without the water cycle, we wouldn't have rain coming back down and then on top of mountains and then moving rocks down. The sun also drives wind because of density differences in the air. So when there's hot air on top of cold air, this creates cold fronts, warm fronts. This also creates all the winds in higher and lower latitudes. So we need the sun to have weathering. What happens on the moon stays on the moon. So when the moon gets hit by something, guess what? That crater is there to stay. It doesn't really have a whole lot of wind at all. It doesn't have a water cycle. It doesn't have plate tectonics. So the moon does not have weathering or really erosion. There are 2 types of weathering that we're going to talk about today. The first one is mechanical weathering, and that's when there's physical forces that break down the rock into smaller pieces without changing the rock's mineral composition. Really take note of that mineral composition there. So we'll get into the examples of mechanical weathering in just a bit. For chemical weathering, there's some type of chemical reaction that changes the rock's mineral composition and changes it into new compounds. So that's really the difference between the two. So we're going to talk about now examples of mechanical weathering, and then we'll get to chemical weathering. Our first type of mechanical weathering is one of the most important ones, and that is frost wedging. This is how frost wedging works. Ice has a density of 0.91. We're talking about ice like water solid state. Water has a density of 1. So what ends up happening is that when water freezes in a given volume, it will expand by about 9%. And this creates a tremendous outward force. So when there is even a tiny bit of water in a crack or something in like a road or in rocks, the water will seep in, and then overnight the water will freeze. And it will cause the crack to expand by, guess what, 9%. And then the water will thaw out again, and then more water will be able to enter that crack, and then the night will come and it will freeze and then expand yet again by around 9%. So this is how cracks become potholes on the road. And you can see over, look at your sidewalk outside or your driveway outside right now and wait over the winter, then check it out again in the spring, and you will see that there are new cracks in that driveway because over the winter water will freeze and thaw. You can do your own science experiment in your freezer by throwing a water bottle in there and then taking it out after it freezed you'll see that the water bottle expanded by 9%, but this is probably more middle school or elementary school. So, you'll know what happens. You can do it if you really want. Go for it. Our second form of mechanical weathering is uploading. You're probably least familiar with this one. So underneath us is something called bedrock. And this rock is solid. If you dig long enough, you can probably get to it. So anyway, 10,000 years ago, when there was glaciers right here that were about a mile high, the glaciers would start to retreat. And when they would take a massive amount of weight off of the ground. And originally, when the glaciers were on top of the ground, they were pressing down all this bedrock that it was on top of. And when the glaciers began to retreat and erode and melt away, the bedrock had this massive amount of weight lifted off of it. So it would actually expand and expand above the ground and expand even more to be what we see around us in Connecticut very much, and also all around the world. Like, you can see it very well at Yosemite National Park. So what ends up also happening is continuing weather can cause the slabs of the bedrock to separate off and create something called exfoliation domes. If you ever are driving on the highway around Connecticut, you'll probably see that we've had to dynamite through these large pieces of rocks in order to make like exit ramps and stuff. I remember when I lived in East Haddam, when I was a kid, I would always notice how like it seemed like the road just carved through the rocks. Those are all pieces of bedrock that were lifted up from the glaciers after they left. Our third type of mechanical weathering is known as abrasion. And abrasion is when rocks are crashing into rocks and surfaces, and the friction between the rocks moving against the surfaces and the particles during their transport causes the rocks to break into smaller pieces. And this happens when rocks are in glaciers and they're being mixed up and falling down. This happens when waves are crashing on the beach and forming the silica sand becoming sand. This happens when they fall off of a mountain, and this happens when they roll down a river. So what I really like about abrasion, what I find interesting about it, is if you go on top of a mountain and start picking some rocks, you'll find that the rocks on top of a mountain are very angular and they're very sharp and pointy. But if you go to then the bottom of the mountain and go where there's water, you will quickly notice a difference in the rocks. You will find that the rocks are much more smooth and round because they have endured years of breaking into smaller pieces and being smoothed out by all the other rocks crashing into them, as well as the water. So I just really think that's interesting. Next time you go on a hike, check it out. Our fourth type of mechanical weathering is biological. There's two types of ways this can happen. You can have something called root wedging, and that's when plants wedge into rocks and split them apart with their roots. There's also animals can burrow underneath rocks and cause them to weather away quicker or slower by exposing more of the rock's surface to them. And even some animals can, there's like some worms that can dig through rocks and digest the rock and make their own holes, and there's termites that spit acid and can weather away the rock as well. So yeah, animals and plants can do a whole lot of damage to rocks. So now on to chemical weathering. I have two types of chemical weathering that I'm going to be talking about. And the first one is carbonic acid. Carbonic acid it's a molecular composition, H2CO3, but how it's formed is kind of interesting. So as you know, there is carbon dioxide in the atmosphere all the time, and we humans are said to be putting more of it into the atmosphere. But yeah, it's there, and when it rains, the rain droplets crash into the carbon dioxide in the air, and when it does, they sort of mold together into carbonic acid, H2CO3, and then the carbonic acid will ride on the rain droplet down to the ground. and eventually become groundwater, which is water inside the ground. And eventually it'll find its way usually to a rock that's underneath us known as limestone. And limestone's pretty common around here. It's common in other places around the world. So what's interesting about limestone is has this type of mineral in it called calcium carbonate. And when calcium carbonate is exposed to anything acidic, it dissolves. In other words, it breaks down and dissolves. Limestone has calcium carbonate in it, and when carbonic acid makes its way to limestone, it starts to dissolve limestone away and weather it away, forming caves. So caves are usually composed of limestone, and they're these giant holes in the ground that were carved out from moving groundwater that has an amount of carbonic acid in it, and all of the calcium carbonate in the limestone has been dissolved away. So that's how caves are formed. So chemical weathering is the reason why we have caves. And carbonic acid is also the reason why rainwater is naturally acidic. So rainwater has a pH of 6 to 6.5, even 5.5 is okay for natural rainwater. And just to give you some perspective, distilled water has a pH of 7. Our second type of chemical weathering is oxidation. So oxidation, which you are familiar with, is actually the process of iron rusting. For iron to rust, you need three things. You need the iron, you need oxygen, and you also need water. So what happens is it's a chemical reaction that takes place on the iron in which carbon dioxide from the water, the carbonic acid that we talked about before, mixes with the iron, and an oxygen lets go and then grabs onto the iron. So iron goes from being iron to iron oxide, which is FeO2. There actually really isn't any pure iron in the world. All iron is already iron oxide. And through time, the iron will crumble easily, weaken in the rock. And yeah, that's what rusting is. Rusting is known as oxidation. So now that you are familiar with many types of physical and chemical weathering, I want you to look at your notes and write down ways that a sidewalk could be weathered. I want you to press pause at this time with the video and write down as many examples as you can. So you should have came up with several ways, and I will be checking this when I check your homework. So make sure that you have at least 5, if not more, ways that the sidewalk could be weathered. Now that we have distinguished the different types of physical and chemical weathering, let's talk about the rate of weathering. So there's 3 different ways that rate of weathering can be changed. The first one is the surface area, the second one is composition, and the third one is climate. And we're going to talk more about these in detail in the next couple slides. So for surface area, the way to go is when you have a larger surface area, you have an increased rate of weathering. So when you just have one flat surface, weathering doesn't occur very, very fast. But when you have rocks all around separated from each other, more surface area of that rock is exposed. So it has more sides of it to be weathered, which increases its rate of being weathered down and then eroded away. And when the rocks become even smaller after that, their rate of weathering, how fast that they break down, becomes even faster. So it's almost like an exponential growth of how fast weathering occurs when rocks break down more and more. And these pictures on the bottom show you that the rocks at first began as one piece, and then as smaller pieces began to separate, their rate of weathering exponentially increased. The next way that the rate of weathering can be changed is by the composition that the mineral is itself. So for example, limestone is a type of rock when exposed to carbonic acid. it breaks down and dissolves. But then you take a rock like granite, and it does not dissolve when it's exposed to mildly acidic rainwater. So it stays there. It's a lot tougher. It does not have that type of composition. So the type of rock can affect how fast or slow it will be broken down. And our last way that the rate of weathering can be changed is by climate. So the first one is your temperature. A warmer climate will favor chemical weathering, while cold climates will favor mechanical weathering. This is because cold climates have an increased chance of freezing and thawing occurring, whereas warmer climates do not. Also, the moisture can affect it as well. So if you have more moisture in the air, you can have more situations when there's less wind and when there's more rain, and that would break down the rocks more or less depending on the type of composition it is. So we talked about weathering, and we learned that weathering is really the breakdown itself of the rocks and sediment and soil. But now let's talk about erosion. Erosion is the movement of the rock, sediment, and soil. It's the actual transportation of it. It moves the solids. So there's three ways that erosion and movement can take place. It can be moved by water, such as rivers and streams in the ocean itself. It can be moved by wind, so think of sand dunes in the desert, transporting all that sand from one place to another, as well as on beaches. And then ice. Ice is one that you may not right away think of, but glaciers grow and recede. The reason why we have Long Island is because a giant glacier bulldozed all these rocks and then basically dumped them off where Long Island stands today. Icebergs also move chunks of rock, surprisingly. So these three things is how rocks can be transported, and also solids can move to another locations by the force of gravity, of course. So when you have rocks that are being weathered on top of a mountain, they'll eventually move down the mountain from gravity. And when you have a pile of rocks on the bottom of a bank of a mountain, that's called talus. So there's some interesting things for you on erosion. Our last piece I want to talk about today with weathering and erosion is acid rain. And we're going to be talking about acid rain a lot this year. We'll be talking about it a little bit more in this unit, in the next unit, as well as in the second semester. So acid rain is a pretty dangerous weather phenomenon. It's not what you think it is. It's not like, green water comes down and melts all your clothes and you have to run away naked somewhere and take cover. That's not at all what acid rain is, but a lot of people think it is. Acid rain is actually occurring most of the time it rains. Rain is naturally acidic, but when it is more acidic than usual, that's when we call it acid rain. And it's a chemical weathering process that is due from increased pollutants like nitrogen oxide and sulfur dioxide. And don't worry if you don't know what those are. We're going to talk about those next semester when we get into quarter 3 and we talk about air management. So it really makes the atmosphere, it can really make the atmosphere poisoned in certain places, damage the soil, damage the water, damage the animals that live in the water. It can also weather and erode buildings and statues. So buildings and statues can be chemically weathered from acid rain. That's why we're talking about it right now. So here's some pictures that show what acid rain can do. So if you take a look at the picture in the middle here, you can see that this statue once looked like this, and after years of acid rain, it looks like this. So this isn't just one rainstorm and went from this to this. This is quite a few. And then you can see gravestones can lose all the lettering because of acid rain. This was once a gargoyle. Now you can't see the eyes or anything. Even forests all the leaves can burn off from a really, really bad acid rain storm. The Taj Mahal is battling acid rain every year, and they have to keep rebuilding it and trying to figure out how they can save it and salvage it, because each year it's a little bit worse from the acid rain, because I think it's made of marble. It's made of some rock that can be chemically weathered away and has limestone in it, which breaks down because of the calcium carbonate inside of it. So what I would like you to do now is I would like you to answer these questions in your notes, and I am going to be checking these for them to be answered. And make sure you write a decent definition for the first question. What is the difference between weather and erosion? I'm going to tell you now that I am going to be looking for that, as well as the rest of these questions. Credits for some of the material of this video goes to Leslie Joseph. Alright guys, so that's all I have for you today. I have 2 videos here that I'd like you to click on. The first one on the top left will show you a song that involves weather and erosion. I think it's really helpful and helps you review. And on the bottom right, we have our good friend Bill Nye the Science Guy. And he's going to talk about erosion and weathering as well. He has some really good labs that he does. So make sure that you do watch both these videos and help yourself review. Alright, thanks a lot guys. Take care.